Hello, my name is Nordin Malango. I happen to be a data scientist for one of the banks here in Malawi. Um, but currently, I'm taking a course on Coursera on machine learning foundations for managers. Um, and in that particular course, we have been given an assignment on trying to come up with a simple model that would be able to predict electrical energy output. Um, which actually uses a combination of gas turbines as well as steam and heat recovery generators. So in this we have a data in this particular project we have a good number of features or a good number of features in our data set. And our data set has temperature that ranges from 1.8 degrees Celsius to 37.11, and it has ambient pressure, and we also have another feature, relative humidity, and then we have exhaust volume, which is being represented as a V. So relative humidity is RH, ambient pressure is AP, and temperature is T. And we have now the net hourly electrical energy output, which is being represented by a PE. So here in this particular problem, in our particular model, we want to be able to predict the PE using the four features. So before we get started into the modeling itself, uh, we need to do a little bit of expert data analysis for to enable us to understand the data itself. So in this particular assignment, I'm using NumPy as well as Matplotlib and Simpon to plot our graphs, as well as Pandas for loading our data sets and doing some data manipulations. So if we start to do that, we would be able to load all the necessary libraries. And here we are simply importing the data, which is cpp data.csv. And then eventually the next stage is where we are trying to find more information about the datasets. So this is trying to figure out if there are any other missing variables, if there are other non-null variables, what kind of data type does our data have. So the info what it gives us is you see that there are 9,568 entries, and of which we have five columns as stipulated above. And then in this we have all them are not, we don't have any missing values in that, and we don't have any narrow values. And is of float type, it means it contain numbers that are actually decimals. If you will want to get deeper into trying to understand, we can actually describe our data sets. In from this we can be able to get the mean, what is the standard deviations, what is the minimum value, what is the maximum value, of which you already outlined it in the previous. But here we can be able to capture um, the mean, which is the average of our data sets. And here it just shows how spread our data set is. And another stage is where we want to just simply see a sample of how our data looks like. So in terms of expert analysis, we can see that everything is fine, and we have been able to get the mean, the maximum, and they're all in good ranges. We don't necessarily need to standardize or normalize or do based on the simple models that we're going to have. So here, in terms of the more, you can see that the features that we have from the explorated analysis, it's continuous. We want to be able to predict a continuous variable, which is the PE. And since it's a continuous variable, the kind of the problem or the approach that we're going to take is going to be that of a regression rather than that of a classification, because classification mostly deals with the categories, not with continuous targets. So in this particular regard, we're going to look at regression models. So here is we need to be able to determine which actual models do we need to use, and as well as which features do we need to use. So the next stage is where we want to look at different features we have. As I said, we have quite a good. We have four features that we're using to predict the PE. So here I'm just trying to put it into X and Y values, where the X is where our features is going to be, and our Y is where our target will be. So the next stage is where I'm using mutual mutual info integration from the SK library, which allows us to actually see how relevant is our features in relationship to the target itself. So here I've defined a little bit where I'm actually computing the MI scores, and here I'm using the Seaborn libraries in order to be able um, to actually visualize the mutual information scores. And as you can see, AT is scoring higher than the rest, and also we have a V which is a little bit closer to one. You can say it's about 0.98 or something. So you can see here that the most important actually relationships that are there between our features to our target is actually the AT and as well as the V and as well as the AP, and lastly by the RH. So in terms of module building, it means the most important features from this is where we have the AT and V. So what we're trying to do when we are trying to depict our to choose our module, we're going to we can start with AT and V because this actually shows the linear relationships that are there. So if we had to do that, to just visualize, you can see here the plot of AT against the PE. We have that linear relationship, even though it's a kind of going in the opposite directions. As the AT increases, the PE actually is decreasing. And as such, you also have a plot of V against the PE, of which as the V also increases, we have the diminishing of the PE. So you can see actually a clear linear relationship that is there between those features as well as the PE. And then here we go now to the other ones like the AP. Yes, there is a relationship, but we can distinguish. That's why even when you go to the mutual information scores, here it's a third on the list, and it's quite worse now when you go to the RH itself, where the relationship of our scatterpod doesn't really make sense. So if in terms of the model building, what we are going to do is first of all try to from this uh, one, you use the training test split to split between the training set as well as the test set. And I'm going in this particular assignment, I'm going to compare two models, which the first one is the linear regression model and the other one is the random forest regressor. So, and I'm using a metric mean squared error. As I said, this is a continuous problem. So as such, I've just chosen to use one of the metrics that I can use to compare the two. So I'm going to use the mean squared error. And as such, in the beginning, what we can do is actually test from the two features that were our best. So if we use the two features, what will happen eventually is you see that linear regression in terms of mean squared error is has 24 and the regressor has 13, simply because the random forest regressor is able to capture some of the nonlinear relationship that is between the features and the likes. So we can either try to add um, another feature to see how the performance will actually improve if we add another. Let's say we add the third one, which is the AP. So if we add the AP in here, let's see how the performance will be. So you see that there's no really significant change in terms of the linear regression, but there is quite a significant change when it comes to the random forest. We may as well say, okay, in this particular program, we're going to use all our features, but I want you to notice something that if we go and actually test, including the RH in our model, you see here, initially we have 23 and 10.9. So if we run this using the new thing, you will see that there isn't really much difference because the other one is quite 10, and the other one as well previously we had close to the same figure. So as you can see, this feature, the last one, is not necessarily any importance to our model. As such, we may test our model based on those three features, where is the AT, the V, and as well as the AP. So if we do that, and you can see that the consistency here is where we have uh, we have the random regressor with the mean squared of 10.9, and we have the linear regression mean squared error with the 23. As such, on the model, we are going to actually choose that the random forest regressor is our best model for our problem, and we're going to use that to actually predict the electrical energy output in this particular project. Just a little bit of interpretation on that one. You the choice of the model also depends on many other factors, which one may also include the interpretability that we want. So in our problem, what we are more interested in is the predictive accuracy. So as such, in terms of interpretability, linear regression is the best rather than the random forest. But random forest has also an advantage that it can be able to identify non-linear relationship that is there between the features and the target. As such, it's good when it comes to the accuracy. As such, because it's minimizing more on the mean squared error, which is a 10.9. So as such, as I said, if you are more interested in the interpretability of your model, then linear regression is the best. But in this case, because we're only focusing on the predictive accuracy of our model, then our choice of the model is simply the random forest regressor. Thank you very much.